Welcome to our channel. Today we're diving into the most dangerous places in our solar system. Buckle up because this is going to be a wild ride. From scorching temperatures that would melt lead to supersonic winds that could tear apart a spacecraft, our cosmic neighborhood is full of hazards that make even the most extreme environments on Earth seem tame. But these dangers are also opportunities to understand the universe's extremes, to test the limits of our technology, and to appreciate the preciousness of our own planet. So get ready to explore the perils of our solar system. We're going to journey from the sun's fiery corona to the icy plains of Pluto, encountering volcanic infernos, toxic atmospheres, and radiation belts that would make even the bravest astronaut think twice. First stop, Mercury, the smallest planet in our solar system and the closest to the sun. You might think that means it's a blazing inferno all the time. Well, you're half right. Mercury experiences some of the most extreme temperature swings in our solar system. On the side facing the sun, temperatures can soar to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But here's the kicker. On the side facing away from the sun, temperatures plummet to minus 290 degrees Fahrenheit. That's a temperature swing of over 1,000 degrees Fahrenheit. Imagine going from a pizza oven to a freezer instantly. That's Mercury for you. This extreme temperature variation is due to Mercury's thin atmosphere, which is practically non-existent, and its slow rotation. So, while Mercury might seem like a fascinating place to visit, you'd better pack both your oven mitts and your parka. Next up, we're visiting our neighbor Venus, often called Earth's sister planet due to its similar size and mass, but don't let that fool you. Venus is a cautionary tale of a planet gone wrong. Imagine a planet shrouded in thick, yellowish clouds. Sounds beautiful, right? Wrong. These clouds are made up of sulfuric acid, the same stuff used in car batteries. And if that wasn't bad enough, the atmosphere is almost entirely carbon dioxide, trapping heat and creating a runaway greenhouse effect. The surface pressure on Venus is 90 times that of Earth, equivalent to being 3,000 feet beneath the ocean's surface. And the temperature? A scorching 900 degrees Fahrenheit, hot enough to melt lead. Venus is a hostile, unforgiving environment, and even our toughest robotic probes have only survived for a few hours on its surface. It's a stark reminder of the dangers of a runaway greenhouse effect, and the importance of protecting our own planet's delicate atmosphere. Now, we're heading to the largest planet in our solar system, Jupiter, a gas giant with a swirling storm that's been raging for centuries, the Great Red Spot. This isn't your average hurricane. This colossal storm is twice the size of Earth and has been swirling for at least 400 years. Winds inside the Great Red Spot reach speeds of up to 400 miles per hour, twice as fast as the most powerful hurricanes on Earth. Imagine being caught in a storm twice the size of our planet with winds that could rip apart a spacecraft. That's the reality of the Great Red Spot. Scientists are still trying to understand what fuels this massive storm and why it's persisted for so long. But one thing's for sure. The Great Red Spot is a testament to the raw power of nature and the awe-inspiring forces at play in our universe. Chapter 4. Saturn's Radiation Belts. Next we journey to Saturn, the ringed jewel of our solar system, but beneath its stunning beauty lies a hidden, danger-intense radiation belts. Saturn's magnetic field is over 500 times stronger than Earth's, trapping charged particles from the sun and creating radiation belts that are far more intense than those surrounding our planet. These belts are so powerful that they can fry spacecraft electronics and pose serious risks to human health. Imagine trying to navigate through a minefield of invisible high-energy particles. That's the challenge of exploring Saturn's radiation belts. While these belts make it difficult to study Saturn up close, they also create a spectacular light show in the planet's polar regions, visible as auroras that dwarf Earth's northern lights. Chapter 5. Io's volcanic activity. Our next stop takes us to one of Jupiter's moons, Io, the most volcanically active body in our solar system. Forget about gentle lava flows and glowing craters. Io is a volcanic nightmare. Imagine a moon covered in volcanoes, hundreds of them erupting at any given time. Io's surface is a chaotic landscape of lava lakes, volcanic plumes, and sulfurous deposits that give it a distinctive yellow-orange hue. Some of Io's volcanic plumes reach heights of over 250 miles, spewing molten rock and sulfurous gases into space. These eruptions are so powerful that they can even be seen with large telescopes from Earth. Io's intense volcanic activity is caused by tidal heating from Jupiter's immense gravity, which constantly stretches and squeezes the Moon's interior. It's a reminder that even in the cold depths of space, heat and energy can create some of the most dramatic and violent phenomena in our solar system. Chapter 6: Neptune's Supersonic Winds. Now we're heading to the farthest planet from the Sun, Neptune, a gas giant known for its striking blue color and incredibly violent winds. Hold on to your hats because things are about to get gusty. Neptune is home to the fastest winds in our solar system, reaching speeds of over 1,200 miles per hour, faster than the speed of sound on Earth. Imagine a jet stream so powerful that it could circle the entire Earth in just over 16 hours. These supersonic winds whip around Neptune's atmosphere, creating massive storms and cloud formations that are constantly shifting and changing. One such storm, the Great Dark Spot, was a massive storm system that raged for several years before disappearing. Scientists are still trying to understand what drives these incredibly powerful winds on Neptune. Some theories suggest that the planet's internal heat and rapid rotation play a role. But one thing's for sure, Neptune is a reminder that even in the farthest reaches of our solar system, nature's fury is on full display. Chapter 7: Pluto's Icy Surface. Our journey takes us to the edge of our solar system, to the dwarf planet Pluto, a world of ice and mystery. Pluto's surface is a frigid expanse of nitrogen, methane and carbon monoxide ice, with temperatures plummeting to minus 387 degrees Fahrenheit. That's colder than any natural temperature ever recorded on Earth. Imagine a world where the air you breathe could freeze instantly, and the ground beneath your feet is harder than steel. That's the reality of Pluto's icy surface. Despite its frigid temperatures, Pluto is a surprisingly dynamic world. Recent observations have revealed evidence of ice volcanoes, vast nitrogen glaciers, and even a possible subsurface ocean. Now we're venturing into a region of our solar system that's both fascinating and potentially dangerous, the Asteroid Belt. Located between Mars and Jupiter, the Asteroid Belt is a cosmic shooting gallery of millions of rocky remnants from the early solar system. These asteroids range in size from tiny pebbles to dwarf planets hundreds of miles wide. Imagine navigating through a cosmic minefield, where even a small asteroid impact could spell disaster for a spacecraft. That's the challenge of traveling through the Asteroid Belt. While the Asteroid Belt might seem like a chaotic and dangerous place, it's actually mostly empty space. Our next stop takes us to the icy wanderers of our solar system comets. These dirty snowballs are remnants from the formation of our solar system, composed of ice, dust, and rocky material. Imagine a giant snowball, several miles wide, hurtling through space at thousands of miles per hour. That's the reality of a comet nucleus. As a comet approaches the Sun, its icy surface begins to vaporize, creating a glowing coma, and often two tails, a dust tail and an ion tail. These tails can stretch for millions of miles, creating spectacular displays in the night sky, but comets can also pose a potential hazard. If a comet were to collide with Earth, the impact could be catastrophic. Our final destination takes us to the heart of our solar system, to the star that gives us life, the Sun. But don't be fooled by its life-giving warmth. The Sun is a giant ball of plasma, constantly undergoing nuclear fusion and releasing enormous amounts of energy. And nowhere is this energy more apparent than in the Sun's corona, its outermost atmosphere. Imagine a region so hot that it reaches temperatures of millions of degrees Fahrenheit, hotter than the Sun's surface itself. The corona is a dynamic and unpredictable environment, constantly changing and erupting with solar flares and coronal mass ejections. These eruptions can release billions of tons of plasma into space, traveling at millions of miles per hour. If a powerful solar storm were to hit Earth, it could disrupt our communication systems, knock out power grids, and even damage satellites. Thanks for joining me on this cosmic adventure to explore the most dangerous places in our solar system. From the scorching heat of Venus to the icy plains of Pluto, we've encountered some of the most extreme and hostile environments imaginable. But these dangers also remind us of the incredible diversity and power of our universe. They challenge us to push the boundaries of science and technology, to explore new frontiers, and to appreciate the delicate balance that makes life on Earth possible. So, the next time you look up at the night sky, remember that behind the beauty lies a universe of wonder, mystery, and yes, even danger. Keep exploring, keep asking questions, and never stop being curious about the cosmos.